Hi everybody and welcome to another edition of Mr. Douglas's Math Lessons. Alright, today we're going to be taking a look at the wonderful world of Pythagoras. Yes, that old ancient Greek guy gave us some pretty cool things. So we're going to check out Pythagoras, see how it all works out, and in the challenge section we're going to be looking at squaring and cubing binomials. Alright, let's get to it. So today we're talking about Pythagoras. And this guy is so famous. A couple things. A lot of you will have heard of this equation. So this is the Pythagorean theorem. C squared equals a squared plus b squared. And it's pretty cool. Does a lot of good things. But did you know that actually the Babylonians first perfected this? And they called it not this equation, obviously, because there was no Pythagoras then, but they referred to it as perfect triples. And what it basically meant was for any right angle triangle, so here's a right angle triangle, that means there's 90 degrees right there, that if you squared the hypotenuse, and the hypotenuse is this side right here, so this side right here, if you squared it, and we'll call it C, if you squared it, it equaled the sum of the other two sides if you squared each of them. So that is where c squared is equal to a squared plus b squared. And they said that was perfection, perfect triples. And you would find stuff in the Babylonians of tablets or square or like rectangles that had these dimensions. And later on, around 540 BC, Pythagoras came along and got all famous. So it just goes to show you, not everything that you hear is always going to be true. Sometimes you have to dig a little bit deeper into the history of things to find out where it is. So this is kind of actually a Babylonian thing, but we're going to call it Pythagoras today. So that's the basic of it. You can use this for right angle triangles, and we're going to go through some examples and see how it all works. So here we go. So here's your cool right angle triangle. And we'll start off, I would say, pretty easy. Let's just call this 12. So that side is 12. And we're saying the hypotenuse is 20. And we're trying to find out this side right there. So here's our equation. So c squared is equal to a squared plus b squared. And let's go and replace things. So this would become, and I'll use brackets just to be very obvious. So that's 20 squared. Does it matter if you call this A or B? It doesn't. These two sides right here are interchangeable. It doesn't matter. So just for fun, I'll call the 12 the A. And then we're trying to find out what B is. So let's just go and do some of our math. So 20 squared is 400. And 144 is equal to B squared. Oh, sorry. It's going to be plus B squared. Let's get that eraser there. There we go. And you can probably already start to guess that we're going to have to use some of our knowledge dealing with roots. So I'm going to go and subtract 144 from both sides. And that is going to leave me with a b squared is equal to, gosh, it has been a long day. What's that going to be? I think 256, so 256. Okay, so how do I get b all by itself? Because we're solving for b, we're not solving for b squared. So I'm going to go and just square root both sides. And you might know the square root of 256, of course, is going to be 16. So 16 is equal to b. So this side up here, this side is 16. And that would make this a perfect triple. Okay, so that's kind of the idea there. Sometimes you'll get questions where you might be asked to answer, is this a right angle triangle? So is this? A right angle triangle? Because it should follow c squared equals a squared plus b squared. So let's say, I don't know, this was Maybe not 12. We'll say, should we say it's 12? No, we already used 12. Let's say that this was 10, and this was 4. And then the hypotenuse, which is the long side, the hypotenuse is 15. So is this true, basically is what they're saying. Well, let's go and do some math. So remember, this is C, and these two sides, it doesn't matter, can be A or B. It's up to you. So is 15 squared, is it equal to 10 squared plus 4 squared? That's what we're really asking. And if you go and you square the 15, you get 225. So 225, is that equal to 100 plus 16? Well, no, no, it's not. So it is not a right angle triangle. So that's how you can go and prove stuff. Sometimes you're going to have questions that are going to have radicals as part of one of the sides. So let's take a look at how that'll work. Let's just go and say the hypotenuse was actually 2 root 5, and we knew that one of the sides was 4. So remember, our equation was c squared equals a squared plus b squared. And I'm just going to put some brackets on here just to make it really obvious what we're doing. So there's some brackets. And let's go and plug in. This is our hypotenuse. So the hypotenuse is c. So it's going to go right in here. So we get a little 2 root 5 there. And remember, this can be a or b. It doesn't matter. So I'm going to throw it into a. And I'm going to say this is the unknown side. So I'm just going to call it x. And just put x there. Everybody likes x as the unknown. So you have to go and square everything. So we have to go and square 2 root 5. So if I'm going to square 2 root 5, I'm really meaning 2 root 5 times 2 root 5, which would give me 4 root 25, which is really 4 times 5, which is really a very complicated way is to say 20. So this is 20 is equal to 16 plus x squared. I'm going to go and subtract 16 from both sides. And that will leave me with 4 equaling x squared. Now, of course, we're going to solve for x, not x squared. So I need to take the square roots. And if I take the square roots, that would leave me with 2 equaling x. So don't be freaked out if you do have, some radical stuff as an actual side. It's not too bad. You just go and plug it in. It works the exact same way, and just use all your radical skill knowledge, and you will be absolutely fine. So there's a little bit of information on good old Pythagoras, and let's move on to challenge.
So for challenge today, we're going to be looking at taking a binomial or maybe even a trinomial, and how do you go and square it and cube it? Is there a shortcut? Is there a long way? How do we go and do it the most efficiently? Let's take a look at that and see where we go from there. All right, here we go.
Let me warn you, we are in for a treat for this challenge stuff. It's going to involve something called Pascal's triangle. Now I know you're saying this is a lesson about Pythagoras, but we're going to switch it up and we're going to look at Pascal's triangle. You might have heard of it. It is so cool. So this guy Pascal was playing around with numbers, as you do, way back when there was no, Pokemon or the internet. Can you imagine there was no internet? And he started to see some patterns with triangles. And this is what he started to kind of come up with. Imagine this is going to turn into a triangle. So here's eventually what our triangle will kind of look like. And he started to make a very simple pattern. And I'm just going to put a couple of zeros here. And what he basically started to do is he started to add two numbers together, and then below it, put the sum of those numbers. So I'm putting those zeros there for a reason. So 0 plus 1 gives you 1. 1 plus 0 also gives you 1. The sides of the triangle always start with 1. That was one of his little rules. So if you always had 1 starting like this, he just kind of wondered, what would happen in the rest of the triangle. Well, let's just continue the pattern. So here's the first, and he actually didn't call this row 1, which is actually pretty important. He actually called it row 0. He called it row 0, and this was actually row number 1. And then I'm not going to bore you, but you can see the pattern, obviously. And so what he ended up doing is what's 1 plus 1? Well, that's 2. So remember, you're getting that by simply adding those two numbers, and that's what you get. And let's just continue the pattern now. So 1 plus 2, that would give us 3. 2 plus 1 would also give us 3. So again, we're just continuing that pattern of adding those numbers together. To get that to you, we'll do one more row, just for fun. 1 plus 4 is 4. 3 plus 3 is 6. And there we go. So there's the first, what is that? 1, 2, 3, first 4 rows, the first 4 rows of Pascal's triangle. Now this triangle is magical. These numbers appear everywhere. And by what I mean by these numbers, I mean these patterns. So when we're taking a look at this, you're going to notice in math that these series of numbers, 1, 2, 1, appear in places, and it kind of makes you wonder, how does the universe have this happen? It's really cool. This is one of the things that really gets me excited about math, is seeing these kinds of numbers just be popping up in different places. So where might these things come in handy for you, the math student? Well, we'll take a look at one thing, and we're going to take a look at a binomial theorem a little bit. So we're going to use this idea. So you got it? Here we go. Say goodbye to the triangle. So we're going to take a look at squaring and cubing, binomials and trinomials. It's going to be fun. And first off, let's go back down a little bit of memory lane. And remember that when we are squaring a binomial, so we're squaring this one, what that really means is, of course, a plus b times a plus b. And if you've seen some of my videos or you've been in my class, you know that we use FOIL, first, outside, inside, last. And there is a shortcut. And the magical shortcut, and I like using the shortcut when we're squaring a binomial, when we're squaring one, is you square the first term. You multiply them both together. So if you multiply them together, that's AB. But then you double it. So it's 2AB. And then you square the last term. So that's the pattern. Now, let's just take a look at that pattern. What's the coefficient in front of each term? 1, 2, 1. What? 1, 2, 1? Wait a second. Hey, I remember 1, 2, 1. There is 1, 2, 1. And remember when I was talking about rows? Well, what row does 1, 2, 1 appear into? It appears in row 2. This is seeming a little bit fishy. Let's go back. And where would we see a 2? Oh my gosh, it's right there. So you're telling me when I square a binomial, I'm getting a Pascal triangle pattern? That's crazy. I wonder if we can keep seeing that pattern. Well, I'm glad you asked. You didn't really ask, did you? Let's take a look and see what happens. What happens if I do it to the third? So a plus b cubed. Well, if this is a pattern, and okay, I'm going to, spoiler alert, it's a pattern. This 3 indicates the row of Pascal's triangle. So we should be expecting the third row and the coefficients of the 4 terms to follow 1, 3, 3, 1. That's what we should be expecting. Does it happen? Well, I don't know. Remember, this means a plus b times a plus b times a plus b. Oh, that is kind of crazy to go and do. I've seen students do this quite the long way, by hand. And you can do it, and you'll get your answer. Well done. Congratulations. But don't we want to be more efficient? I'm all about teaching you the efficient way. So let's just assume that that pattern is right. So that pattern for the third row is 1, 3, 3, 1. 1, 3, 3, 1. And I'm telling you right now, it is. So this is kind of what the pattern goes, and you're going to be using A and B in these ones. So a couple things to keep in mind is that the sum of the exponents of the term have to equal what you're doing up here. So the sum of the exponents have to equal 3. And we also have to be even in our distribution. And I want you guys to think about kind of a nice kind of, I guess, a semicircle like that. And it's kind of going to go 3, 2, 1, 2, 1, 3. So it kind of goes up and down. When you see the pattern, it becomes a lot easier. So the very first one is just taking the very first term and putting it right here. Okay, so that's just, a cubed. Does the exponents equal 3? Sure, 3. And then we know that the next term has to start with 3. And we have to use our two terms in here. So what's a times b? So a times b is just going to be ab. But we have to also have our exponents equal to 3. Right now it's just 1 plus 1. Well, that's not going to work. So we're going to put a 2 here, and I'll just put a 1 there, just to make it very obvious. And then our third term is also the 3. And we're still going to multiply our a times b there. So we're going to get ab. And again, our exponents have to equal 3. So we just went 2, 1. So we're going to go, 1, 2. Typically you're probably on a math paper, you wouldn't put the 1. And then finally, you're going to have the last term. So the very last term is going to be just b, and this will be cubed, like that. And that, lo and behold, is what the answer is if you went and did that by the long ways. So that's kind of the idea. So you can see kind of Pascal's triangle helping you out for squaring binomials like that. And let's take a look at one more. Oh, hey, I just got a message. Did you guys hear that? That's exciting. Let me go and get rid of that. And let's go and take a look at one more. And this time, we're going to try it with something else maybe a little bit more challenging. Let's do it with something that says 2x plus y. And we're going to cube it. Just like that. And we're still going to find, we're looking at the third row. And the third row pattern, just so you guys know, is 1, 3, 3, 1. So 1, 3, 3, 1. Just like that. And again, it's the very first term. So I'm going to use lots of different colors here. So it's the very first term. And I'm going to go and just kind of set up this question so you can kind of see how it all kind of works. And I'll use some brackets and some colors. I think the brackets and colors really do help. And I'll use some exponents as well. Let's go put in some numbers in now. And remember, we have to use our terms here. So I'm going to put my 2x in there. And of course, we still have our other things we're going to go and put in here right now. So let's go put in my 2x in that one. And of course, we're multiplying them together. So I'll put my y for that one. And I'll put 2x here. And we're still multiplying, so I'll put my y. But for the last term, it's just y itself. It's just y. Let's go throw in our exponents now. It has to equal the total of 3. So the very first one is a cube there. For this one, it's going to be kind of the pattern of 2, and then 1, and then it goes 1, and then 2. And the last one is just 3. So you can see the kind of the patterns happening there. And now let's go and do the actual math. So let's go and do the actual math now. So 1 times anything is going to be itself. So we just have to go and cube 2x. So if you cube 2x, you end up getting 8x cubed. Oh, I forgot. We're adding all these, right? We're adding. There we go. This is going to be 3 times the square of this times y. The square of 2x is just going to be 4x squared. 4x squared times 3 is going to be 12x squared. Don't forget the y. Over here, this is pretty straightforward. This one just ends up being 6x y squared. And finally, we're just going to go and cube the y. And there you go. Easy peasy, as they say. Now, we're going to kick it up another notch. You're like, kick it up another notch? Are you crazy? Well, that was Pascal's triangle that we saw. So that was Pascal's triangle right here. That's Pascal's triangle. Very cool. There's something called Pascal's tetrahedron. Tetra what? Tetrahedron. So let's go and take a look at Pascal's tetrahedron. And this is going to help us with cubing trinomials. What? Cubing trinomials? I know, it's going to be crazy. So let's take a look at what happens when you are cubing a trinomial. So here's our good old trinomial. So a plus b plus c, and we're going to cube it. And we're talking about a tetrahedron, which is kind of like a triangle kind of thing. So this is going to be kind of cool. And how does it all play out? Well, it's going to be the same sort of idea. Let's take a look at some other things before we get into this actual question. If we went and had a trinomial here, and I put it to the 0 power, that would give us 1, of course. And if I put this to the first power, that would just give itself a plus b plus c. But if I did it to the second, well, then we start getting into some interesting things. If I did to the second, I kind of get a mini, let's use a dark green color. I kind of get a mini triangle that would kind of look like this. We're going to start by making this, actually maybe take a step backwards. What would this one look like? So what would the to the first power look like, to the first power? Well, it would look like this, so A, B, and C, just in the corners there. And we're going to use this idea. This is kind of like combining algebra and geometry, kind of making what things look like. So if I went to the second power, we would use sort of the same idea, but instead of putting a in the corner, we'd put a squared and b squared and c squared. And then what you got to kind of be thinking about a little bit is kind of what happens there is how are we going to be filling this out. And this is where you're going to use some of your Pascal's triangle ideas as well. So if I'm going to the next thing, I'm going to look at this side with a squared and b squared. So I'm going to multiply them and have a double of it. So it's kind of like a 2ab. And over here, I'd have a 2ac. And across the bottom here, you'd have a 2bc. So what would you get for your answers? Those are all the terms that you'd end up getting. And what you'd be getting, your final answer would sort of be like, let's go way over here. You'd get an a squared plus 2ab plus 2ac plus b squared plus 2bc plus c squared. Oh, it's craziness, right? Absolutely craziness. So what happens, back to our original question, is like, what happens when you cube a trinomial? What happens when that happens? And I think we need a brand new page for that one, don't we? For sure. Let's make our giant triangle. Let's be it like this. The sound effects. And remember, we're going to cube a plus b plus c. We're going to cube it. So the same sort of idea. We're going to go and put our a cubed, b cubed, and c cubed in the corners. And then again, we're going to be kind of looking at cubes, so triples, and we're looking right across here. So what happens here? A little bit. What happens there? So what's going to happen there is we're going to multiply. So a and b. So we're going to get 3ab, and we're not done with that 3ab yet. And we get another 3ab. Again, we're still not done with that. We need to put some exponents on there. So the exponents have to add up to 3. So the first one is going to be maybe 2 for the a and 1 for the b, and the other one is 1 for the a and 2 for the b. And then what happens on the other side? Well, on the other side, of course, you get 3 ac and another 3 ac. And let's put some exponents on these things. So maybe for this a, I'll put, I don't know, let's do 1 and 2, and maybe here we do 2 and 1. And then in the middle, so the middle one, we need to do something in the middle right here. So what are you thinking? Like, what's that going to look like? What would probably go there? Well, I'm thinking that we would probably have a 6. So you put a 6 there. What color should we use? Let's put a 6 right here. So this kind of comes down to the idea of, and a 6, ABC. This is like right in the middle. So this is a 6 ABC. Does the exponents add to the 3? It sure does. And then what's going to kind of happen down here with our B and our C? We're going to get a 3 BC, a little bit darker, 3 BC, and a 3 BC. Let's go and fix our exponents. So those are all nice. And maybe I'll put this like a 2 and a 1 and then a 1 and a 2. And there's all your terms that you'd end up getting. So what would your final answer would be? It's going to be kind of crazy. So it'd be like a cubed plus 3a squared b plus 3ac squared plus 3ab squared plus 6, I'm running out of room, abc plus 3a squared c, well, we're going to go over there, plus b cubed plus 3b squared c plus 3bc. Why did we start this question? Well, let's finish it off. Plus c cubed. Whew. Okay, that was the craziest question of the year, definitely. So that's what you end up getting, and this is the fast way to do it. So this is kind of taking a look at some stuff that you might, if you're really into math, kind of take a look at, tetrahedrons, and looking for patterns. And again, this all kind of comes back to the idea of Pascal's triangle and using that kind of idea for combinations and stuff. So I hope you enjoyed all that and have a great day. Whoa, where'd that just come from? That's cool. All right, let's finish it off. There we go. Thanks, guys.
Thanks everybody for checking us out today. Hopefully you guys took away some stuff. Pythagoras, binomials, cubing, squaring, good times in math land. Until next time, cheers.